Okay, so we're going to look at circles with tangents. And you have to remember that from our geometry chapter that a circle, or a tangent, sorry, to a circle. So we look over here. So say we have our circle. A tangent is a line that hits a circle at one spot only. So like at one point only. So that circle hits the line there, say, or if we had another one, it could hit it here or whatever. But it's only hitting at one point. So before we've seen like chords that'll go through it at 2 points and whatever. But our tangent is it only hits at one point. The really important thing to remember about a tangent is that the radius, if we drew in the radius to that circle, which would be the centre point to any point on the circle, it's perpendicular to the tangent. So the radius, the slope of the radius is going to be perpendicular to the slope of the tangent. So if you multiply the slope of the radius by the slope of the tangent, you should always get -1. And we look at a question like this. So just remember the perpendicular. So you remember this kind of shape. It's perpendicular. That means they meet at two 90-degree angles, which they are doing there. And that their slopes, if you multiply their slopes by each other, you get -1. So just for example, if we said the radius slope was 3/4, so we worked it out, we used the 2 points, then we know the tangent slope is going to be flip that and change its sign. So -4/3, and if we multiply 3/4 by -4/3, you get -1. Therefore, perpendicular. Okay, so it's just kind of a quick recap. So what we're moving on to then, so a tangent is a line. So if you're asked to find the equation of a tangent, it's actually the equation of a line. So you have to remember what two things do I need for a line, a point, and a slope. Just don't forget that. But we're looking at a circle question now. So I'll just zoom in a bit. So this is the circle, x plus 2 all squared plus y minus 3 all squared equals 100. So they've drawn the circle for us. If we had to draw the circle ourselves, we'd have to figure out like what is the centre of this circle. So say they didn't even have the graph there and they just gave us that question. What's the centre of this circle? So we know our formula for the circle is x minus h all squared plus y minus k all squared equals r squared. And we find the radius as well as the centre. Radius really easy. We know r squared is equal to 100, because if you can see here, r squared is the place where 100 is. Therefore, r is equal to root 100, r is equal to 10. That's really straightforward. But the centre, we have to look at the minus h is equal to plus 2. So if minus h is equal to plus 2, then h is equal to minus 2. And if minus k is equal to minus 3, k is equal to 3. And we know our centre point is hk, so it's going to be minus 2, 3. If we look over here in the graph, that is the case, minus 2, 3. If we want to talk about calculating the radius of this graph, a really, really easy way to do it is count across. Remember I was saying your x-axis or your y-axis. So like if we count across our x-axis, so like that's 1 unit, 2 units, 3, 4, 5, 6, 7, 8, 9, 10 exactly. Therefore the radius is 10. So that's one way of doing it. But there's a question, this was an exam question. So they call this point up here P, and they ask you, given that the point P was minus 8, 11, so that is minus 8, 11, that's P here, and it's on the circle, find the length of the radius. So you know from the centre to any point on the circle is going to be the radius. You could have found the radius without knowing P, because you counted from the centre point to a point in the circle, and we just used our x-axis, and that was able to tell us that was 10 units. But we can also use the fact that it's they've given us P. So say P is equal to minus 8, 11, and the radius is equal to, not radius, sorry, centre is equal to minus 2, 3. So what they're actually asking us to find here, they said given that P is on the circle, find the length of the radius. So the length from the radius to the point in the circle, so you know it's going to be the centre to the point in the circle, you know it's going to be the radius. So that's going to be distance of a line because it's a length. So it's coordinate geometry, sugar, X, label your points, fill in your formula, x2 minus x1 squared plus y2 minus y1 squared. So I don't need to put that equals in. Square root of minus 2 minus 8 all squared plus 3 minus 11 squared. Square root of minus 2 plus 8 all squared plus minus 8 all squared. That will give us the square root of minus 2 plus 8 is going to be 6 squared plus minus 8 squared is going to be 64. So 6 squared is 36 plus 64, that's going to be square root of 100. We know root 100 is going to be 10, so your radius is equal to 10. So we've calculated it from P, the distance from P to the centre, as 10, which is obviously the same as what we were talking about earlier, but in this case they asked us when P is there, but you should be able to identify if there's a point there, or if you just want to read across your axis, sometimes it's a bit easier. The last question that they want to ask is find the equation of the tangent at the point P. Okay, so we talked about equation of tangents, and we know that they're lines that hit in one spot. So if we just drag a line here, hang on a second, that's not very good. She's my mouse. Delete that, so that's P there. So if we drag P, and we just, yeah, so that's sitting on the point P, so that's our tangent to our circle P. Okay, so what we spoke about earlier about tangents are perpendicular to the radius. So we know if we find the slope of the radius, so we found the slope of radius, we know that the slope of the tangent is perpendicular to that. So we'll find because you have to remember, equation of the tangent, you know, that's a line. Therefore you need two things. You need a slope and you need a point. So they're asking us to find the slope of this line here. Not the slope, sorry, the equation of this line. We know the point because we have one point here. You know that this point is minus 8, 11, but you don't know the slope. So at the minute we know the slope, or the point, minus 8, 11, but we don't know what the slope is. So you have to find the slope, and tangents we know perpendicular. So we can find the slope of the radius. So if we use these ones here, this point here, this here, because that's our radius points. That was this point first. This point, we find the radius of that, the slope of that radius, sorry. So our formula was y2 minus y1 all over x2 minus x1. So that gave us 3 minus 11 all over minus 2 minus minus 8, which was equal to minus 8 over plus 6, which is minus 4 over 3. So the slope of the radius was equal to minus 4 over 3. I'm sorry, I'm kind of rushing this. I'm on a time limit here. I've only a minute left to do this. Minus 4 over 3. So the slope of the tangent was then going to be, so you have to change the sign, so we get rid of the minus, flip it around, 3 over 4. So that's your slope of your tangent. You know they're perpendicular because if you multiplied minus 4 over 3 by 3 over 4, you would get minus 1. Therefore, they're perpendicular. So find the equation of the tangent P. We need just to know two things. We need to know the point and the slope. So we now know the slope was 3 over 4, and we knew the point was minus 8, 11. Slope of a tangent is a line. You go to your log tables. You find the equation of a line is y minus y1 equals x minus x1. Fill in. So this is x1, y1. So y minus 11 equals 3/4 on x minus minus 8. Remember that this 4 has to go across.